all right. Good evening, students. Welcome to one more session of your WOC. This is your Vani ma'am back again. How are you all doing, students? All right. So, as promised, we've already started with your handwritten notes for the upcoming board examinations. Yes, till date, I think, yeah, I have sent the amines chapter. After that, I have sent you the haloalkanes and haloarenes chapter. So today we are going to see the next upcoming chapter, the most important chapter. That's nothing but aldehydes, ketones, and carboxylic acids. You very well know the weightage of the chapter is maximum. Yes. So I have covered every line of NCRT in this. So when you open your NCRT book after studying the notes, you will only get to know that every line of NCRT and every word of NCRT is clearly covered in this. And most important is you'll be able to answer exactly whatever notes are given here. If you write the same answer, you'll be getting the same, I think, the complete marks which is mentioned in your question paper book. That means you'll be getting the complete marks as prescribed for each question. Let's start with the video. To all the students who have joined me for the first time, welcome. And the students who are associated, my gratitude from my heart. Thank you so much. So let's start. The chapter which I've chosen today is your aldehydes, ketones, and carboxylic acids. Now, students, as you see this is a particular general formula because you are going to study about the ketones, aldehydes, acids, acid chlorides, esters, and amides. Yes. So I have just given the general formula and the category of what we are going to study. From there, this chapter, gradually when I take, the most important thing is nomenclature, structure of carbonyl compound. So basically the common name and IUPAC name. So in your exams only the IUPAC name is what is asked. So I have given the common name here, and from here actual concept starts, students. That's nothing but your IUPAC nomenclature. As I have mentioned, I have taken the example, I have taken the common name, I have taken the IUPAC name also. Got it, students? So here what happened? Here I have taken benzaldehyde common name. Okay. Here acetophenone common name, propionephenone common name, like that. Little variation. I have started with the aliphatic thing. Here you all have the common names prescribed. Here you have the IUPAC name which I have mentioned gradually with the numbering system. So almost 7 examples here, and almost, if I have to tell you, 15 to 20 examples will be covered, students. Yes. So these are the most important IUPAC nomenclatures which you should compulsorily study for the examination. All right. From there, gradually after the IUPAC nomenclature, I have taken you into a concept that's nothing further dealt. Further, I said no, there'll be more than 20 examples. So on both the directions, 1 to 13, and gradually I have taken the different oxo compounds also, aromatic, aliphatic, everything I have covered, students. So what happens when you have two aldehydes? What happens when you have a C double bond O? What happens when you have a carboxylic acids? So all put together I have mentioned in this particular sheet. This covers your aldehydes, ketones, and carboxylic acids. Gradually from there, I have taken you after your IUPAC nomenclature, common name and IUPAC, I have taken the concept of structure of carbonyl compound. So basically, they may ask you one more question of what is the structure, why the bond angle is so much, why is it trigonal planar, why it is like that. So I have clearly explained the structure of carbonyl compound. My request is, all the students, I request you to please watch the one shot videos because I have covered every line of NCRT. That's very, very important. From there, gradually, I have gone into a topic after structure. Yes, let us see what is the concept. Yes, the continuation of the structure, why it is, why the carbonyl compound groups, why is the chemistry, why the carbonyl group governs the chemistry of aldehydes and ketones, why, what is the specialty of this carbonyl group. This is what I have mentioned. I have given the reasons also. This is how I mention the reasons with showing the arrows. After, based on the concept of the structure of the carbonyl compound, both, I have extended this further. Little few empty spaces are there in between, students, only while clicking the camera, the photo. So I have explained what is the reason, what happens because of the carbonyl group, how is the electrophile attacking, what is the due to the electronegativity difference, why is the bond polarized, everything I have explained. So all put together from the structure, the complete reasoning is given till here. From there, I'm going to conclude or take the particular thing with that concept, and then start with the preparations of your aldehydes and ketones. So here I've given the preparations of aldehydes, here I've given the preparations of ketones, here aldehydes and ketones. So there are certain reactions which only aldehydes show, there are certain reactions which only ketones show, there are certain reactions where both aldehydes and ketones show. So I have mentioned it here. So after the IUPAC nomenclature, after the structure, you can note all these reactions. Again, I have already done the, please remember, one shot videos. So you can watch the one shot videos which is kept in the playlist. Okay, yes. Then students, now gradually after the preparations, this is one more preparation which is shown by both aldehydes and ketones. Ozonolysis reaction, hydration of alkynes. Now in detail, let us go into the topic now. The first important thing, reduction reactions. So preparation of aldehydes. So these are only aldehyde preparations where I've given the name reactions as Rosenman reduction, Stephens, Dibal with the reagent Dibal. What are the reactions? So all the three put together, everything is given. Maximum, whatever is the possibility required for your board examinations, everything I have mentioned. In this particular sheet, you can also learn the conversions also, students. Yes, for example, acyl chloride converting into your aldehyde. They may ask you, convert nitriles to aldehyde. So convert your esters to your aldehydes. Like that, using your Dibal reagent, I have given maximum all the possibilities data. After the reduction reaction, students, gradually we are going to go into a concept called Itard reaction using chromyl chloride. Here I have given in the boxes. In the exam, you can write in the same way. Itard reaction, what is converted to what is the reagent, what is the product form. Yes, done. After the Itard reaction, then comes gradually the next topic, that is oxidation. Now reduction is over, now oxidation. For oxidation, I am using the reagent CrO3 and gradually forming benzaldehyde. So what is the reaction also I have given below. So reduction is over, now oxidation process. From there, if clearly students, I have mentioned the reagent, I have mentioned the reactant, I have mentioned the temperature conditions, what is the final product, where to name, everything I have mentioned, you can directly write it in the exam in this way. After that, gradually come down. Now we are going to use or go to a process called hydrolysis. First we have done the reduction, then we did the oxidation, now we are doing the hydrolysis. I am using aqueous KOH for this. That the product formed as aldehydes. From there, I've also taken you into a concept that's nothing but preparations of ketones. Now, aldehydes, all preparations of aldehydes like reduction, oxidation, hydrolysis, etc. Now, I have taken you into preparation of ketones, that is from nitriles. I've shown you step-by-step formation. After that, second, Friedel-Crafts acylation, where I'm converting your benzene into your aromatic compound. So, I'm preparing the sorry, little calf students. So I'm preparing the final product and I have shown you from acyl chloride, Friedel-Crafts acylation reaction, both how they are converted forming the final product. Using cadmium chloride also I have given here. This is a very important reaction, students. Alright. Gradually from there, your ketones. Now I have given a reaction which are shown by both aldehydes and ketones. Here in this case, oxidation of alcohols, dehydrogenation of alcohols. Both oxidation, what is the reagent used? Dehydrogenation, what is the reagent used? The final product formed also I have given. Gradually from your preparations of aldehydes and ketones, by that now we are going to see the ozonolysis reaction and hydration reaction. Completely mechanism also I have given here. Examination they're going to ask you what are the final products formed by hydration of alkynes. So I have given the reagents, I have given the product, temperature conditions, everything. From there, students, gradually let us go into the next concept, physical properties. So now all the preparations are over. Now physical properties, one question they will ask you. So based on the dipole-dipole interactions, what is the concept? What will happen to the boiling point? After that dipole-dipole, I have taken you into the next concept that's gradually coming back based on the solubility. So because of the hydrogen bonding present, what happens to the solubility in aldehydes and ketones? I have given that with increasing alkyl group. This whole concept includes your solubility. From there, gradually, I go into the next topic, that is chemical properties. So believe me, students, every line is covered in this. So you can directly write the answer. If the question is asked to you, you can directly present your answer in this way. Now, chemical properties, the most important of your chemical properties. Remember why actually aldehydes and ketones undergo nucleophilic addition. That's the concept. So I have given the reason also. You can note it. And again, I'm mentioning I have done one shot videos with all the every line of NCRT explanation. Please go to Google and type it as World of Chemistry, aldehydes, ketones, and carboxylic acids by Vanimam. You'll get the topic. Done. After the chemical reactions introduction, now we are going to go based what is the order of reactivity towards nucleophilic addition. So formaldehyde, acetaldehyde, and ketones. So the first nucleophilic addition reaction with HCN. How is the cyanohydride form? I have shown you step by step. From there, after HCN, students, hope I'm going slowly. After HCN, I have given the note also. This is where the examiner is going to ask you. From there, addition of NaHSO3 also is given step by step. Then gradually, after NaHSO3, again I have given a note where the examiner is going to ask you. And this is an important reaction for the Grignard's reagent using RMGX, how formaldehyde is converted to primary alcohol, acetaldehyde to secondary, and ketones converted to tertiary alcohols. So this is the reaction which is given and along process with hydrolysis. In detail, I have expanded the reactions. When I expanded the reaction, I have shown you step by step. See here, step by step, how primary is formed. Yeah. So from there, same mechanism follows for acetaldehyde. Here what happens? Here I have taken formaldehyde. Instead of that, you will be having CH3 here. Instead of CH here for ketones, it will be one more alkyl group. Procedure is the same. The attack will be around the carbonyl group. After that, reaction of alcohols is what I have taken. So gradually, I have taken formation of hemiacetals and acetals. Now from the nucleophilic addition reactions, proceeding further, ethylene glycol is one reaction which I have taken, ethylene glycol. So in the presence of dry HCl gas, I have shown the reaction and formation of glycols is what I have done. From there, nucleophilic addition reactions, gradually we are going to go with the ammonia derivatives. I'm sorry. Let me just scroll. Okay. This is ammonia derivative reactions. Basically, how is the ammonia derivative? Because this Z is going to change, right? So I have given the general reaction first, where the addition product we get, and gradually I have taken the different products of that. Now, after the ammonia derivatives, taking the different examples, as I said, Z will change. In this case, hydroxylamine, then hydrazine, then semi-phenylhydrazine. So all the reactants, removal of water, products are formed. I have shown this in this reaction. From there, gradually I have taken into 2,4-phenylhydrazine. This is also instead of that Z, we have 2,4-DNP, which is here, where hydrazines are getting converted to hydrozones by the removal of water molecule. I have shown you clearly, no confusion at all. Right, students? Now, from there, I have taken you after your product, semi-carbazide is left. The Z indication, semi-carbazide. So, hydroxylamine is there, hydrazine is there, semi-carbazide is there. So basically I have included all in this page. 2,4-DNP is there. Then last one is your semi-carbazide, which is there. Carbazide getting converted to carbozones. After your nucleophilic addition reactions, next comes your reduction reactions. Reduction with different reducing agents like this. Right? So now the reduction, I have taken the examples as I said. So different reduction, one is Clemmensen reduction, one is Wolff-Kishner reaction, where aldehydes and ketones are getting converted to alkenes. So in this case, I mentioned the this one name reaction, the reagent. Below, I have taken the reaction and shown you. Yeah, students. All right. So here, no, I had next page I have shown you, students. And here, what did I do? I have taken the different reducing agents like nickel, hydrogen, addition of hydrogen in the presence of nickel, platinum, palladium, lithium aluminum hydride, sodium borohydride. All reagents put together I have given here. Done. Now, next important thing, the name reactions. As I said, in the presence of ethanol also I have given. Then Clemmensen reduction, as I have mentioned there, here I have expanded the Clemmensen reduction. Whether it is your aldehyde, whether it is your ketone, generally I have taken, specifically also I have taken here, whether all are getting converted to alkenes. Done. From there, gradually I have taken you into Wolff-Kishner reduction, which happens in the basic medium. So I've expanded clearly here. So with what happens in Wolff-Kishner reduction, so hydrazines, how they are converting into alkanes, both. Yeah. After Clemmensen and Wolff-Kishner reduction, then comes our oxidation reaction. Very important thing. So oxidation reaction, we are using strong oxidizing agents like HNO3, KMNO4, dichromate. Mild oxidizing agents which we are using is toluenes and phenolics. So in the toluenes reagent, I have shown you the formation of silver mirror in this reaction. Here, aldehyde are getting converted to acids, oxidation rather. After the toluenes, see here, what in the biology, chemistry lab, they're going to ask you what is toluenes reagent, formula and name. After that, after the toluenes reagent, gradually I have taken you into a concept of Felling's test. And they have two solutions, Felling's A and Felling's B. Both the solutions I have shown here. Then after that, I have shown the reaction where we get the brown precipitate, which indicates the presence of aldehydes in the lab. Here I have given you the formula also of the particular Felling solution B. Now, then haloform reaction, very important reaction. So where we are getting the iodoform, if you're taking that particular, instead of X, if you're taking iodine, you'll be getting iodoform. If you're taking Br, you'll get bromoform. If you're taking Cl, you'll get chloroform. So this reaction of haloform also is very important, students. So name reactions, 3 marks is what you're going to get. From there, gradually, I have taken into the haloform reaction. Then next came the aldol condensation. So aldol condensation, first comes the definition, then comes the reaction, then comes the base, sodium hydroxide, and finally I have shown step by step how I have removed water and finally getting my alkenol. So bute to enol, because I have taken here 1, 2, 3, 4 carbons. Here I am getting the product as bute to enol. So again, detailed explanation of the video I have done in the one-shot videos. Please go through the one-shot video, students. You will get a clear understanding. After this, now gradually we are going, instead of sodium hydroxide, here I am using barium hydroxide. Here I am getting ketones. Here from there, next I am coming back to one more, that is barium hydroxide, where both the compounds condense to the removal of water molecule, and finally I am getting a pent 3-ene-2-one because we have taken ketones here. So go through the reaction. I have given the names. I have given the product names also. After that, gradually I have gone into cross aldol condensation. I have also used in my videos a trick to remember cross aldol condensation. You can go through the video, one shot videos. Any reactant they give you, I can within seconds you can predict the product. So cross aldol condensation, with that different combinations. Here in this particular page, I have shown you the cross aldol condensation product, where to shift, where to remove water molecule and finally get the product. What temperature also. After that, gradually we are reaching into Cannizzaro reaction, disproportionation reaction. One is getting oxidized and one is getting reduced. Which one is getting oxidized, which one is getting reduced also means same compound, both. Here I am taking formaldehyde. The same compound is getting oxidized, same compound is getting reduced. But here we are using concentrated KOH, which is what I am trying to say. Earlier it was dilute sodium hydroxide, the barium hydroxide, but here I am trying to give you concentrated potassium hydroxide. From there, gradually I am shifting into the electrophilic substitution reactions, easiest one rather. After your aldol condensations, after your hydrolysis, after your hydrogenation, everything, reduction. Now we are going to go to the alcoholic substitution reactions. So here, one second, students, one second. All right, students. Let's resume now. One second. Yes. Now in the electrophilic substitution reactions, we are continuing with that. One second, please. There's an echo problem. All right, students. So now let's come back. This is your regular substitution reactions, which I have taken in the conversion of benzaldehyde to nitrobenzyaldehyde. Now, last one is the carboxylic acids. Structure is what is given here. Then preparation methods. Little I'll zoom in. These are the preparation methods. All I have combined together and kept in one page. Then physical properties along with the question which is asked in the board examination. Answers were also given here. Solubility concept is taken here. Chemical reactions rules. Reactions involving cleavage of OH bond. Questions based on acidity concept, very, very important. Question is given, answer is given. This is how you need to write the answer. One more question. Further, one more question. Effect of acidity due to substituent groups. If electron releasing groups are there, what happens? Electron withdrawing groups are there, what happens? This is an echo, students, I think. Sorry for the inconvenience. From there, order of acidity. Now, some more questions on your order of acidic nature. Arrange the following based on the acidity. This is one more important question. Very important question. One more question based on their acidity. Concept of given. Now, here reactions involving carbon OH bond. Earlier it was OH bond in the acidic group. Now it is carbon OH bond. Mechanism of esterification. It's a 3 marks question which you would get. From there, reactions of acid with acid PCl3, PCl5, so Cl2. Reaction with ammonia. Now, last is reactions involving cleavage of COH bond. Carboxylic methods is very important. Now, reactions involving cleavage of this R group. All we have taken OH, COH cleavage. Now, alkyl group. One is your H-basic reaction. Yes. Then comes your ring substitution reactions. That's it. Perfect. So this is the complete chapter of your aldehydes, ketones and carboxylic acid students. This covers everything of your NCR. So I request you to please share the video. Already I have shared alkyls notes, amines notes. This is aldehydes. I'll meet you again in the next video. Thank you so much. Please subscribe to the channel. Please share the notes to everyone.